Welcome back. In this video, we're going to be talking about linear relations and functions. A linear relation is a relation that has a straight line graph, and a nonlinear relation is a relation that is not linear when graphed. In this section, we're going to be talking about linear relations. We'll look at nonlinear relations later on in the year of Algebra 2. So for right now, we are just looking at those relations which have straight line graphs or straight line relationships. A linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. A linear function is a function with ordered pairs that satisfy a linear equation. Any linear function can be written in the form f of x is equal to mx plus b. So you'll notice that that is function notation. F of x is equal to mx plus b for the equation of a line. We want to make sure that we know that both m and b, when we're looking at linear functions, this mx plus b equation, those are real numbers in the real number system. So that must be true. So if a linear function is a function with ordered pairs that satisfy a linear equation, and a linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant, I want to decide whether each of these functions is a linear function. The way we're going to do this is kind of by combining these two pieces. If I can manipulate what's here into looking like mx plus b, I'll know I have a linear function. On the other hand, if I can't make it look like mx plus b, or if it has some other operation of the variable, I'm going to know that it's not a linear function. So when I look at this first equation here, f of x is equal to 8 minus 3/4 x, I can rearrange this to be f of x is equal to negative 3/4 x plus 8. In this case, my m value from the form mx plus b is negative 3/4, and my b value is 8. So yes, this is a linear function. For my second g of x here, when I'm trying to manipulate this to look like the form mx plus b, I really can't. And the reason is that I have a variable in the denominator. Addition, subtraction, and multiplication of a variable. This is actually division of a variable. So this is not a linear function. So this is not linear because you cannot divide by x, or you can't divide by the variable. If I look at h of x, this is already in the form mx plus b, where m is equal to negative 3/2 and b is equal to 1/3. So this is a linear function. For j of x, I can't get this into the form mx plus b because of this term here. This is x to the power 2, which means this is x times x. I can only multiply a variable by a constant. I can't multiply a variable by itself. So x squared, this is not linear because x squared is not a valid operation for a linear function. If you look at the graphs of each of these, if you were to graph them on your calculator, you would see that f and h both graph to be lines, while g and j do not look like lines. They have a curve to them.